at trig integrals. And the only part that we're going to be working with, though, is the power reducing identities. So these would have been within the trig unit that you studied in Honors Math 3 or Advanced Math, depending upon where you came out of. And so we're only going to be working with the sine squared and the cosine squared. So these are two identities that you will have to memorize and be expected to know for the chapter test, the AP test, the final, anything that is involved in some sort of assessment. So the identities that you learned last year, you did for sine, cosine, and tangent, but we're just going to have to for sine squared and cosine squared. So these are the two identities that we'll be working with. But in particular, so this is how you viewed them, in your trig unit in Honors Math 3. But we're going to actually just have this 1/2 coefficient component always be written out front. So although it's written that way, the way you learned it, the way we'll use it is 1/2, and then times 1 minus cosine of 2u. So if your angle here is, say, 40 degrees, this would be 80 degrees, right? So double. And that way we can pull that coefficient out. And then our cosine squared form, similarly, we'll have that 1/2 component pulled out to the front so that when we go to use this for integration, we'll just treat it as that coefficient. So what's nice about that is we don't know the integral for sine squared, right? That's like beyond our list of, of formulas that we have to memorize. So we use a trig identity to reduce the power, hence the power reducing identity, because we do know how to integrate just cosine. And so that is something that we have. Okay, so let's go ahead and take a look at this first question. And so we want to find the integral of sine squared. So again, that's not something we know. So we're just going to do a trig substitution. So we're going to use a sine squared. So this one right here is what we'll replace. And then in this particular problem, our u is x. And so we will have 1/2, and then the integral of 1 minus cosine. And then we double the angle, so that would be 2x. And then we're going to integrate with respect to x. And so then from here, we just integrate each of those pieces. So the integral of just 1, right, with respect to x would be x. And then minus, and then this one I'm going to do separately just because we're going to have to do a u du. So that would be cosine of 2x and then dx. Okay, so all I did was integrate the 1, right? And then now when I take a look at this part, I have a 2x here. So that means I'm going to need to let u equal 2x because that's my inside piece. And then that derivative is 2 dx. But I just have a dx here, so I'm going to have to divide the 2 over. And so then I would have the 1/2 on the outside. And then when I do my substitution, I'll have the integral of the cosine and then replace 2x with u. And then dx is going to be 1/2 du. And so that 1/2 only goes in front of the integral, so don't yank it all the way out to the front. And then we have that. And so then now my last little bit here, so I would have 1/2 and then x minus, still have that other half. And then the antiderivative of cosine is positive sine, right? And then u, which is just 2x, and then plus c. And then I could certainly distribute in the 1/2, not that I have to, but I could do that. And I wouldn't distribute it to the constant because it would just be another constant. If I wanted to use subscripts to distinguish if they're different values, I could do that, but not necessary. All right, so if you think you got it, go ahead and try example 2. Otherwise, or press pause and try example 2 on your own. Okay, so let's go ahead and look at this one. So again, we don't know how to integrate the cosine squared by itself. So we're going to go ahead and use the identity here. So we're going to use the cosine squared version, which is the same as the sine squared, but the sum instead of the difference. So the sine is a subtract. Catch that S, sine is subtract. Okay, cosine is not. All right, so let's go ahead and do that substitution. So I will have the 1/2 that I'll pull to the front, and then I'm going to integrate, and then 1 plus, and then cosine, and then I'm going to double the angle. So it was 3x, so now I'll make it 6x, and then we're going to integrate with respect to x. Okay. So for this one right here, I'm going to go ahead and do my UDU substitution at the same time. So let me scoot this around a little bit. So for this one here, so I know I'm going to have to do the UDU, so I'm going to do that just right now. So I would let u equal 6x, and then that derivative is 6 dx, but I only have a dx, so I'm going to divide by 6. So I have 1/2, and then this is going to group out, and then the integral of 1 with respect to x is x, plus, and then right here I'm going to do a UDU. So I have the 1/6 here, and then the integral of cosine u and then du. So I just basically just skipped this step right here, right? And I'm just jumping down to here. So then I have the 1/2, and then x plus, and then 1/6, and then the integral of cosine is just sine of u, and then u was 6x, and then plus c. And I can leave it like that. I can distribute the 1/2. I can even have the plus c outside of the bracket as well, because that would be kind of the same idea. And then that's the end of that.